Hello guys and welcome back to another video. Today we are going to be talking about our apple catcher game. In the previous video we instantiated we defined three classes: text, player, and food, and in this video we're going to be actually looking at how we are going to be instantiating them, creating instances of them in our code. So if you run our code right now, nothing is going to happen, right? There's nothing there. But when we start instantiating our turtles, there will be things present. So let's take a look at that. Okay, dokie. So we have our food list, player list, and our score list. This might be something new to you. Why aren't we instantiating, like, for example, so as you can see, we have a list. We have a food which is presumably our apple, and another food which is presumably our banana by the names, right? Then a monkey and a farmer. Now you might be wondering, why are we storing this in a list? The reason for that is because this makes support for adding new foods and players so much more easier. Why create a whole nother logic for food, right, with different point values and different attributes and stuff, when you can just add it to this list, right? Why, like, let's say I want to create a third player with different controls. Instead of completely instantiating a new one as a new variable, I'll just store it in this list. And you probably still don't appreciate why this is so helpful, but when we get into our game loop, right, where we constantly have a loop running and checking things, you'll see why this is so helpful for us. Okay, now as you can see, the score list is empty, and that's because we have to instantiate our score, our text turtles a little bit differently, because we have to instantiate them based on the number of players there are, and we have to do a bit of math to see where it's positioned. So let's take a look at that. Wow, so that is a lot of code, okay? But I'm going to go through it line by line and make sense out of things for you. The first thing is we created a n players variable to keep track of the number of players in our player list. Then I want to start positioning our scores based on the number of, x coordinates there are. So next I want to make sure that I keep track of exactly where we're going to start keeping our scores. That's why I want to access the top right coordinate, which is, remember, the negative screen width divided by 2. So if you have a screen width of 800, remember that our XY axis splits the screen in half, and half of the screen is negative and half of the screen is positive. If you don't know what I'm talking about, research the coordinate plane or check out our first video where we talk about the coordinate plane. Or you can just ask one of the YCW tutors, of course. Now, I'm using a for loop, and you might have not seen this in a while, actually, maybe not even since, reading and writing from files. Who knows? But basically, what we're doing is, for each of the players, we are going to position our score turtle in a certain way. And there's logic, mathematical logic to this, so if you don't get it, don't worry. You can ask us, or you can leave it as is. I'm not expecting you guys to get this logic yet, but if you guys are in 7th or 8th grade, try to make sense of it, right? Okay. So our section width. So we're basically going to be splitting up our scores into sections. So our section width for each score is going to be screen width divided by n players. So let's make sense of this. If you have 2 players, then each of our scores will take up a section of 400 coordinates, right? If you have 4 players, it'll take up a section of 200 coordinates, right? Then we need to find which x position we want to place our score in, right? And then what we're doing is we're basically from the top right x coordinate. So the top right is basically, think about it, the top right x coordinate. From there, we are going to add that to the section width, which is like, let's say we have 2 players, right? So the section width right now is 400. So we're going to take the top right chord, which is negative 400, right? And then the section width is 400 times I. So I is first 0, right? Plus 5. So don't worry about this plus 5. I just want to give a little bit of space. So let's do the math here, right? Let me do it in actually a comment. It makes more sense this way. Okay. So top right coordinate is negative 400 in this case. The first section, right, will be 400 since you have 4 players. But then remember, in our for loop, since we're going in a range of n players, this actually I will always start at 0. So we do 400 times 0 plus 5. This equals negative 395. This is basically the top right. We're basically placing this at the very top right of the screen. Now the next time the next iteration, which is the second player, I is now going to be equal to 1, right? So negative 400 plus 400 times 1, which is 0, plus 5. Now the x coordinate is 5. So this basically moves the next score 400 to the right. Okay? Finally, we append our text turtle with the x position. And then this is basically saying, okay, you know what? The y value, our screen height divided by 2. Screen height divided by 2 is the very top of the screen, okay? Remember, because it's split into half. And then we subtract 50 to make it go a little bit lower. And then finally, we want the text node to be green, the text to be green. Okay? And then finally, we want to actually paint it, right? We want to paint the text. So what we're doing, we're basically saying whatever the player's name is, right? Because remember, we're taking the player's name right here, monkey and farmer. We're setting its score to 0, and we're formatting it with the player list at index I. So remember, if this is the first iteration, we're using the monkey. If this is the second iteration, we're using the player. And then we're accessing its name. So remember, the name attribute, if you look here, is like monkey and farmer. So this would be like, first, it'll be monkey score 0, and then farmer score 0, and then we write the text, which is this. That was a lot to digest, but let's run the code and see if it works. Okay, so we have our monkey and our farmer initialized. As you can see, our score starts at negative 400, as we expect. And then we have a 400, remember 800 divided by 400 is 2, so our screen is basically split into 2 sections. Our farmer score is, again, split into 2 sections, as you can see. Like this half is for the monkey score, and this half is for the farmer score. If you had 4 players, this would be split into 4 sections, where monkey score would be here, then farmer score would be here, then monkey 2 score would be here, and then farmer 2 score would be here, right? And this makes our code scalable, and that's one of the important things we have to consider. We want our code to be able to build upon itself. We don't want to, write extra code for every single score. We don't want to do that. I don't want to hard code that. I want my program to do that for me. And that is the logic for this score text algorithm. Okay? Now, the last thing I want to talk about in this video is our game loop. Now, this is different from main loop. Main loop basically makes it so that our code doesn't exit even after we finish running everything. As you can see, when we run this, our code finishes, right? But the window isn't closing. Our main game loop, which we're going to use a while true loop, right, is basically going to every tick of the game. Tick is basically every iteration of the game. We are going to be doing stuff. And what is that stuff? Let's check that out. Okay, so this is a big algorithm, right? But that's to be expected. This is our main game loop. Everything here, we were just setting up stuff. Now things are actually going to be happening, right? So let's take a look at this. So run game is true. And while run game, so basically what you might expect is that, like, when the game ends, we're not sure exactly how the game is going to end yet, but when the game ends, we're going to set run game equal to false, and then we're basically going to stop the game. The next line is basically update. So as you can see, we're performing a turtle screen update. We're updating the frames, we're updating the screen. This is not as powerful as Pygame's frame updates, but it serves its purpose. Now, this next part is a nested for loop, if you remember what that is. So for player and player list, so we're going to look at all the players here. And then for each player, so we're at our first player, we're going to look at every single food that's there, right? So for every single food that's there, we are going to be checking for collisions with that food. Okay, so let me explain what that means. The first player is a monkey. We're going to check to see if the monkey is near the apple. If it's not near the apple, okay, then nothing happens. If it's near the apple, we're going to get points. Then we're going to go to the banana. Is it near the banana? If it is, it's going to get points. Now we go to the farmer and we do the same thing. Is the farmer near the apple? No, no points. Is the farmer near the banana? Yes, it gets points. If we have another food, then we're going to do that again. So let's say our food list has 4 foods and our player list has 4 players. This is a math question. How many iterations will this run? How many times will this code run? If you said 16, you are correct, because for each player, we have to iterate through the food list. So 4 times 4, which is 16. Okay. Now, one thing I do notice is we don't have to check if the player is near the wall. We don't have to do that. So we can put it out here. So for every player, we check if it's near the wall. We don't have to check also for every food. So this is going to make our code a little bit faster. Now you might be wondering, what does check collisions do? What does check near wall do? I am not going to go over that in this video because then the video would be too long. Instead, let's go to this next part where we update the score, and there are a few cool tricks that we can use here. Let's take a look. Okay, so what we're doing here is for player score text. This is new to you. In zip player list score list. What does this mean? What we are doing is we are parallelly, I don't know if that's a word, but simultaneously iterating through both the player list and the score list at the same time. So remember, the score list right now has X and Y. It has 2. It has 2 elements in it because we're doing this for iron range and players, right? So this is going to be for sure the exact same size as player list. Therefore, we can run a zip on this. And what this means is that the first time we run this, we compare this player to this X. And then we compare this player to this Y. And then let's say we had a third player, right? Player 3. And then we would compare player 3 to Z, right? So it allows us to compare 2 equally sized lists side by side. And this makes sense only if those lists are correlated, right? Because the player turtle is correlated with the score list, because whatever this player's score is, we have to update the score of X, right? And then whatever score the farmer is, we have to update that with the score of Y. Okay? So what we're doing here is if the player score is not equal to the score text.score, you might be wondering what this means. And I will talk about that in the next video. But basically what this is doing is saying if our score text.score is not updated with the player score, right? So the player score, like let's say here in check collisions, the player earns a point, right? Because it eats food. Or like earns like 3 points because it eats like an apple and a banana in the same frame, right? So his score went up by 3. Now the score text doesn't know that. It's behind 3 points. So if it's not updated, then we have to update the frames, right? We have to update the score text. So what we're doing right now is first, we of course are updating the score text score to be correct, right? And then we're basically going to clear the previous score text, right? We're going to wipe that, whatever it drew off the screen, and then write the new score, okay? If this doesn't make sense to you, don't worry. Everything will come together in the next episode. I'm not going to run anything right now because nothing really happens. And of course, the code would break because, as you can see, this has no method called check near wall yet. This has no check collisions yet. It's not complete yet. But in the next video, we will set the player's movement, right? And we will also finish check collisions and check near wall. Thanks for watching, and I'll see you in the next video.